Hello, ladies and gentlemen. It's my pleasure to welcome us to continuation of what we've started on Introduction to Matrix Algebra. Thus far, we have looked at definition of a matrix, various types of matrices, matrix operations, addition, subtraction, multiplication, and we have looked at the properties of matrix operation. We ended the class by looking at determinants of a matrix, which is very, very important whenever we want to compute inverse of a matrix. So today we want to look at how to compute inverse of a matrix. To calculate inverse of a matrix, we need 5 steps. The first step is to calculate the determinants. That's what I said is very, very important. The second step is to get the minor of the matrix. And anytime you want to obtain the minor of a matrix, the procedure is very straightforward. You delete the elements, row and column. Whatever is left is the minor of that particular element. The third step is to calculate the cofactor of all the elements in the matrix. That step is necessary if the determinant is not equal to 0. The fourth step is to get the transpose of the cofactor matrix, and that is what is called the adjoint of that matrix. And so the last step is to calculate the inverse, which is 1 divided by the determinant multiplied by the adjoints. So let's try to go through an example. In this case, we want to get the inverse of this matrix A, which is a 2 by 2 matrix. Let's follow the procedure. Based on the procedure, we need to get the inverse of A. Inverse of A. So we have A equals, that is 3 multiplied by 0, that will give us 0, minus 2 multiplied by 1, that is 2. And that will give us minus 2, that is the determinant. So we say the next is to obtain the minor. Okay, so let's get a minor. Let's call the minor AM. So let's 2 by 2 matrix. So the minor of 3, for instance, cancel this column, cancel this row. What is left is 0. For 2, it will be 1. For 1, it will be 2. And for 0, it will be 3. So that is the minor. So let's get the cofactor. Cofactor. Let's call the cofactor AC. And that's really a 2x2 matrix. It is signed minor, but how do we get the sign? Here is A11, that is row 1, column 1 of matrix A. So 1 plus 1, that will give us 2. So minus 1 is minus 1 raised to power 1 I plus j. So 1 plus 1 will give us 2. So minus 1 raised to power 2 will give us positive. So this will be 0. This is A12. 1 plus 2 is 3. So minus 1 raised to power 3 will give us negative. So here we have minus 1. The whole idea is this. When you add the row and the column and you have even number, then the sign will be positive. And when it is odd number, then the sign will be negative. Or by rule of thumb, you know the first one, which is 1, 1, is always positive. And positive must not follow positive, and negative must not follow negative. So I'm sure this is negative because up there is positive. And I know also that this will be positive because it's A22. And that takes us to the adjunct. Like I said, the adjunct is the transpose of the cofactor. So let's get the transpose. So we want to get the adjunct of A, and that will give us so that will be 0, minus 2, minus 1, 3. Yeah. And to get the inverse, so the inverse equals one divided by minus 2, that is determinant, then multiply by the adjunct. So this 0, minus 2, minus 1, 3. So this will be 0, half, 1, and minus 3/2. So it's very straightforward. So that is how to calculate the structure, let us finish it, equals so this 0, this will be 1, this will be half, and this will be minus 3/2. Good. So that's how to calculate the inverse of a matrix. So try to get the inverse of this 3x3 matrix and work it out and see whether you'll be able to get the answer. Just follow the procedure. So let's quickly look at matrix application. We start by looking at how to apply it to simultaneous linear equation, which is common everywhere. Find the solution to the equation using matrix inversion. We have 5x1 plus 3x2 equals to 30. 6x1 minus 2x2 equals to 8. Expressing the simultaneous equation in matrix form, just extract the coefficients here. We have 5, 3, 6 minus 2. Then you have your x1, x2 equals 38. So what you need is, the solution is this, that is, you multiply the inverse by the product matrix, which is 38. So what you need is just get the inverse of this coefficient matrix. So we have 5, 3, 6 minus 2. The determinant is what? Just, you already know how to get the inverse. The determinant is minus 28. The minor is minus 2, 6, 3, 5. The cofactor is minus 2, minus 6, minus 3, 5. The adjoint is just the transpose of this, is minus 2, minus 3, minus 6, 5. Then the inverse is 1 divided by this minus 28 into this adjoint. So our x will now multiply this inverse by the product, which is 38. So doing that will give us this into minus 84 minus 140. This should be minus here. Yeah. It's minus 28, not 28. And it's going to give us this. And if you work this out, you will get 3, 5. So which means our x1 is 3 and our x2 is 5. Okay. A shortcut approach has been developed. It is called Cramer's rule. It's a practical way of solving system of linear equation and is derived from the matrix inversion approach. So I will quickly put us through so that, because most of the time you'll be using Cramer's rule if you don't want to go through the rigors of inverse matrix method. Find the solution to the equation using Cramer's rule. The same equation. This is expressing this in matrix form. So the procedure is very straightforward. You want to calculate x1. You will replace the first column by this product, 38, 3 minus 2. Then you get calculate the determinant of that one. And the real determinant, which is 5, 3, divided by the determinants here. Okay, you get it. 30 multiplied by minus 2, that's minus 60 minus 24, that's minus 84, just like what we obtained before. Well, we already know that this will give us minus 28, and that is 3. To get x2, it's straightforward. For x2, you replace the second column by this product. Let's see, 5, 6, this. And the denominator is the same, because that is just the determinant we have calculated. So, and that will give us minus 140, minus 20, you can see it's 35. So this is faster and more straightforward. But that is not to say that we cannot test your knowledge of how to go through the problem or solve the problem using matrix inversion, your test, or examination. Okay, so try to solve this problem. Again, please try to solve this real life problem. Another area where it's very useful is in econometrics. But since we are going to register for econometric course, you will still have to do it now. Some of you come across it at master's level. I think by the time you get there, it's going to be straightforward. By the time the teacher is teaching the application of matrices. In fact, it will become real to you more than what we have taught now. What I want to do now in the next slide is to show you clearly how to operationalize all these matrix operations, addition, subtraction, scalar multiplication, inverse, getting determinants, and lots more using our software. So please don't forget to go through the 3 videos: Introduction to Matrix Algebra, Part 1, Part 2, and this part, before going through the last part, which is Part 4, which has to do with the use of R to carry out matrix operation. So thank you. And till I get across to you the 4th video, stay well.